Welcome back. In this video, we're going to pull up and work through one more example of a hypothesis test for a population proportion. So, in the year 2000, 58% of females aged 15 years of age and older lived alone, according to the U.S. Census Bureau. A sociologist tests whether this percentage is different today by conducting a random sample of 500 females aged 15 years of age and older and finds that 285 are living alone. Is there sufficient evidence at the alpha equals 0.1 level of significance to conclude that the proportion has changed since the year 2000? Now notice the key word here, different. We're trying to determine whether the proportion has changed from its value of 0.58 in the year 2000. That implies that we want a two-sided test. And so our hypotheses are going to be HO, P equals 0.58, versus H1, P is not equal to 0.58. But now, before we can run our test, we need to confirm that the assumptions for the test have been satisfied. First, we're told that this sociologist conducted a random sample of 500 females aged 15 years of age or older. And so that satisfies our first condition, which is that the sample is a random sample. Second, we need to check that n times p sub 0 times 1 minus p sub 0 is greater than or equal to 10. So we multiply 500 times 0.58 times 1 minus 0.58, and that turns out to be 121.8, and that is definitely greater than 10. So our second condition is satisfied. And finally, we need to check that our sampled values are independent of each other. Now remember we said that we can check this by checking that our sample size of 500 is no more than 5% of the population size. Well, certainly 500 females aged 15 years of age and older is far less than 5% of the total number in that population. So we can consider that this assumption is satisfied. So, all three of our assumptions are satisfied, and now we can proceed with the test. So we're told that our significance level is 0.1. And now in step 3, we calculate our test statistic. Now first we need to calculate p hat. That's the sample proportion of females aged 15 and older who live alone. That's going to be p hat equals 285 divided by 500, which equals 0.57. And then we plug this value into the test statistic. Now we'll let the software calculate this for us, and it turns out to be z sub 0 equals negative 0.45. Here's the output from StatCrunch. It shows the value of the test statistic is about negative 0.45. and the corresponding p-value is 0.6505. So we write down the p-value of 0.6505 and then sketch in the p-value region on the z-distribution. Now remember that this is a two-sided test. So I'm going to fill in the area under the curve to the left of minus 0.45, but then I need to add the value of positive 0.45 and then fill in the area to the right. Because remember, since this is a two-sided test, the total shaded area out on both tails of the distribution is the p-value. Next to step 5, we compare the p-value to alpha. Since our p-value of 0.6505 is greater than alpha of 0.1, we fail to reject the null hypothesis. And so in step 6, we say, at the alpha equals 0.1 significance level, we do not have sufficient evidence to conclude that the proportion of women aged 15 years and older who live alone has changed since the year 2000.